Today we'll take a look at how you can identify and eliminate render blocking resources on your website and how that can make your website load faster. First of all, what is the impact of render blocking resources? When we look at the rendering film strip for this website, we can see that it starts out with a blank page until eventually content starts to appear. Resources like scripts or style sheets that block rendering are called render blocking resources. If you go a bit further down and look at the request waterfall, we can see that there are two render blocking resources on this website. This CSS file and this JavaScript file. The JavaScript file takes a lot longer to load, and we can see that immediately after this request is complete, that's kind of when the page content starts to appear and when the first contentful paint is marked on the timeline. So what can we do to optimize this? So first of all, we can ask whether this JavaScript file actually needs to be render blocking. If we add the defer or async attributes to it, it will no longer block rendering and the page will start to load much sooner. In Debug Bear, we can actually try this out really easily by going into the Experiments tab and then finding the Defer External Scripts recommendation, which also comes with an automatic experiment. So if we click Add on here, this will mean that we add the Defer Async attribute to all these scripts, and then we can click Run Experiment to see how that impacts website performance. I've already finished running this before, and you can see that the result is pretty significant. So we go from a First Contenful Paint metric of 2.2 seconds to just 1.38 seconds. And from a user perspective, you can also see that there is a big difference if you just watch this video recording side by side. If you go frame by frame, you can see that for a long time on the baseline with the render blocking script, there's nothing visible to the user, while with the defer script, the page is long finished rendering. Another would be to make sure to load additional render blocking resources from the same domain. So you can see that every time you load something from a new domain, it needs a new server connection, as indicated by these little rectangles here. And you can see because this one is loaded from eddypar.com, but this one is loaded from cdn.cookielaw.com. The cookie law script actually first requires a bunch of time being spent on a connection. So that's actually half the time that it takes to load that script. If you contrast that to this CSS file that's loaded from the same domain, the same connection can be reused and it loads much faster. Let's look at another example. In this case, the web.dev website from Google. Overall, the behavior is similar to what we had before. We load the HTML document, then we load all the render blocking resources, in this case mostly a bunch of CSS files, and then after that there are a few main thread rendering tasks before page content starts to appear. Other interesting observation here is that there is one file that is pretty big. So this CSS file, even if we can't eliminate it and it can be render blocking, we can still optimize it by just making it smaller so the client has to download less data to be able to render the website. In Debug Bear, the size analysis feature lets us do that very easily. So this is going to show us a breakdown of the different components in the CSS file. And if we look at this, a lot of this is actually not CSS rules directly, but rather embedded images, like this background image. And if you look through each of these, you can see each of these is just another icon that's embedded in the CSS. But these icons probably shouldn't be render blocking. So if we just take them out of the CSS file and move it somewhere else, then downloading the style sheet should be a lot faster, and we should have a much better user experience. Finally, let's take a look at this website. You can see that there are several different render blocking style sheets, as well as some render blocking JavaScript. But the big problem here is that a bunch of render blocking style sheets are only discovered fairly late. So that's because these are using CSS add import. And if I expand this and look at the request chain, you can see that these are actually imported within this other font awesome style sheet. So that's really delaying the first contentful paint on this website, because first we have to download the HTML code, we have to download the first style sheet from a new domain, kit.fontawesome.com, and then finally, once the browser is almost ready to render, we actually have to start connecting to ka-p.fontawesome.com, and again this is a render blocking script, and we need to create the connection and download the resource at that point. So if you wanted to fix this, the best approach would be to load these different resources in parallel. For example, we could do that by adding a link rel preload tag to the page HTML to load the pro.min.css file. If you want to test the page speed of your own website and see the render blocking resources, go to debugbear.com/test.